What is everything in the universe made of? I'll give you a second to pause this video, write your answer in the comments, and then at the end of this video you can see if you still agree with the answer you gave at the beginning. Okay, you can do that now. Alright, so if you take an object and you break it up into pieces, and then you take those little pieces and you break those pieces up into yet smaller pieces, then you will end up with something that looks a bit like sand, some sort of grainy like set of what we call particles. And if you take those particles and you break those particles up into smaller particles, you might start to ask, well, what happens as we go smaller and smaller and smaller? And this is of course a question that was asked by physicists, and they used to believe that an atom, which derives from the Greek word atomos, which means indivisible, is the fundamental particle, i.e. there is nothing that can be smaller than an atom, there is nothing more fundamental, nothing that an atom is made out of.
There must be some point beyond which we cannot go in the division of matter. I have chosen the word atom to signify these ultimate particles.
But in the late 19th century and into the early 20th century, people like J.J. Thompson and Ernest Rutherford investigated the structure of atoms, the structure of the smallest particles that they knew about. Now, Ernest Rutherford in 1911 showed that there seems to be a positively charged nucleus at the center of the atom, and he established this by firing positively charged particles at gold foil and seeing that every so often they were rebounded off. So this gave us some knowledge of the structure of what was thought to be indivisible atoms. But even though we have established that there seem to be things that are smaller than those atoms, what are those things and what are those so-called fundamental particles really made of? Now, you might think the answer to that is matter. If you think the answer to that is matter, then there's one really immediate reason why that's not correct. And that's because if you look around, you'll see that there's lots of light. And light, which is electromagnetic radiation, is not considered to be matter in physics. So what's the difference between light, electromagnetic radiation, and matter? In order to understand this, we need to talk about spin. When something is spinning round, it has what we call angular momentum. Now, this is just like momentum, but instead of going in a straight line, it's going round. This is kind of the intuitive notion of what we think of when something is spinning. And what we find is that subatomic particles have some kind of intrinsic angular momentum built into them. And we can observe and measure the existence of this property there. So this is the essence of what spin is, but there's another important aspect to understanding spin, and that is the notion of rotational symmetry. Now, if you take something like a vector, an arrow, you can rotate it through 360 degrees or 2 pi radians, and it gets back to its exact initial state. Now, this is true of all 3D physical objects. Some of them will have a higher rotational symmetry. This just means that they can return to their initial state multiple times if rotated through 360 degrees or 2 pi. But what's really strange is that matter particles, like electrons, have a half integer spin. And what this means is you have to rotate them around twice to get them back to their initial starting configuration. That seems kind of crazy, but you can sort of understand it in this way. If I point my finger out to the right like that, and then I turn my hand all the way around, it returns to its initial starting configuration. And that is 360 degrees, 2 pi radians. But look at my arm, it's now bent. It's out of shape. It's not where it was when it started. So if I then rotate my hand around another 360 degrees, another 2 pi, you can see that it finally, now the combined arm-hand system has returned to its initial state. So that's what we would call a 4 pi periodicity, or something like having a spin half. Now, that doesn't mean to say that electrons are literally like arms with hands on the end of them, but somehow they exhibit this kind of weird periodicity where you have to turn them around twice before they get back to the way that they started. And this is the defining characteristic of matter.
Matter has half integer spin, and non-matter has integer spin.
That is the defining characteristic of matter. In the standard model of particle physics, which shouldn't really be called the standard model of particle physics, it should really be called something like the standard model of quantum fields, we have fermions and we have bosons. And it's only the fermions that are considered to be matter particles. Light fits into the boson category, along with the Higgs boson, the W and Z bosons, and gluons. The reason why it shouldn't really be called the standard model of particle physics is that we've known for about 100 years now that particles, or the concept of a particle, is not really an adequate description of the fundamental workings of nature. We need to talk about waves, we really need to talk about fields and waves existing within fields. So the notion of a particle is kind of a very old one, and it doesn't really even make that much sense when you start to think about it carefully. But ultimately, it's a model, it's a map for what we are trying to understand, which is the observations that we make. So a wave is a mathematical structure, a field is a mathematical structure, a particle is a concept and has some kind of mathematics to it potentially, but none of these things really are complete descriptions. There are theories, modern theories of physics that involve strings and other things that may be considered to be more fundamental, but really these are just theoretical. If we're talking about empirical and empirically verified physics, then the best model we have so far is that of fields, quantum field theory. So what are particles made of? Well, they're certainly not all made of matter. But you could say that they're made of energy. But what is energy? Well, energy has lots of different definitions in physics. On the one hand, we can say that energy is mass. One of Einstein's equations, E equals mc squared, says that there's an equivalence between energy and mass. Another of Einstein's equations, E equals hf, says that there's an equivalence between energy and frequency. So energy is frequency. In classical mechanics, energy is defined as the capacity to perform work. So, for example, if I take an object and lift it up from away from the ground, then it gains gravitational potential energy, and the work done is the distance moved multiplied by the force acting against it. So, energy is the capacity to perform work, and work is moving something against a force. So that's another definition of energy. And really, there are quite a lot of different ways that we can think about energy, and there are many forms that it can come in. So are we going to say that everything is made of energy? Well, that kind of makes sense, but the thing is that energy, again, is just a conceptual model. Really, what we're talking about here is different equations and different mathematical structures with different properties. The standard model of particle physics is really just a classification in terms of three quantities: mass, charge, and spin. So if we ask the question, what is an electron? It's really just something that has certain charges, certain mass, and a certain spin. And that's how we categorize all of the so-called particles in the standard model. They're really just sets of these three numbers. Well, charge, there are lots of different types of charge, so it's not literally just three numbers, but essentially these are the three main categories. Ultimately, those are the only numbers that we are talking about when we're talking about what these different types of fields are, or these different types of so-called particles are. So if we really want to ask the question, what is the particle made of? Ultimately, we get down to mathematical models and structures. But when we look around, we see colors, we hear sounds, and we have tastes and we have feelings. So how do we relate these conceptual models to that? And the simple answer is that those models allow us to predict the observations that we have. And those observations ultimately come down to conscious experiences. So you could say that all of the equations in physics are really describing observations that we can make, and ultimately then experiences. So you could maybe also say that everything is made of information, and information can also be related to energy. But even if it's made of information, there's the fundamental quality of what it is like to experience that information. And somehow that has to come in there.
I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing, postulates consciousness.
So, is everything made of conscious experience? And those mathematical models just describe the conscious experience that we have? What do you think? Let me know in the comments. And what did you answer at the beginning? Do you still believe in what you said? If you haven't already watched my other, much longer video on consciousness and the fundamental nature of reality, then I would suggest clicking here. Thanks for hanging out with me today. I hope you enjoyed this video. Don't forget to subscribe. If you don't like this video, click the dislike button. If you do like this video, click the like button. And I'll see you next time.